Hello, I am David W. Parker. This is Programming Today I Learned, Algorithm Series, Episode 10. We're going to be looking at data structures for stacks and queues, so this will be a little bit easier than most things. This is in CLRS, Chapter 10, Section 1. Stacks and queues are dynamic sets in which the element removed from the set by the delete operation is pre-specified. Stacks are implemented as LIFO, last in, first out, and queues are implemented as first in, first out. So we'll go ahead and take a look at what we got here. So we have a stack. We have this top variable specified to 0, and an array. We're going to implement these via array. If it's empty, the top is 0. If we push onto the stack, we're going to add one to the top, and then we're going to go ahead and set the value of this dot top to the x that's since applied. If we pop and it's empty, we're going to have to throw an underflow. Otherwise, we're going to remove one and return that one that we're removing. This is a convenience, so just check out what the values are there. So we can go ahead and we're going to push on 1, then 3, and then 5, show that it is empty first, and then it's not empty. Display all the values as we iterate through. And then we're going to pop 4 times. I'm wrapping this in the try and catch statement here because of this throw underflow that's going to occur on this 4th one here. So as you can actually see here, we have the stacks. We have true and false, that it is and is not empty. We have each of these as being defined methods here. Since we're implementing this via with a 1 index as opposed to a 0-based index, which is why this is undefined here. You'd probably want to implement it differently depending on your language. And moving along, we're displaying our values here and popping them off. And then ultimately we're having the underflow. So pretty simple. Queues are a little bit different. We have a head and a tail. Again, we have our values that are stored. In queue is like push, and we're going to be putting it onto the end of the queue. And this is basically if we have a value of none, we're going to have a tail and head equal to 1. And we're going to increment and the head or the tail depending on if we're enqueuing or dequeuing. Again, we have the values here, which is just a convenience method. So we're going to enqueue 1, 3, and 5, display them, and then dequeue each of them off. So if you see here, we have the 1, 3, and the 5. This time we're doing 0-based. And then we're dequeuing them as 1, 3, 5 as opposed to 5, 3, 1 that we had done with the stack. And again, undefined here. Normally, and this is listed in CLRS, they omitted the underflow and overflow checks. So you could, just like you have up here, you have the throw error, you could have those similarly in here if you want. And you could also remove those from the stack if you'd rather. So this is all good, but it's not necessarily the most efficient. So if you're thinking about higher order languages, you have to think about what's already provided to you. Of course, you may be implementing this in your own new programming language that you're writing. But if you're just using JavaScript, there's a lot easier way to do this because a JavaScript array can be used as a stack or as a queue by default. So it comes with a push function that takes in a value. And you could see what the values 6, 4, and 1 are pushed on here. And then we're going to go ahead and pop these guys off. Actually not logging that out, the length out, but it doesn't really matter. And the 4th one's just going to be undefined, so they don't throw any errors like we did above in our stack implementation. But you'll see that 6, 4, and 1, and then undefined are returned here. So 6, 4, 1, so it is LIFO. Same thing with the queue. You can push on 1, 6, and 7, and then use the shift operator, shift function, in order to grab 1, and then 6, and then 7, and then undefined as well. So just think about what language you're using, and there's probably something already provided to you, but if you want to implement something yourself, now you know how. If you like what you saw today, please subscribe and sign up for my newsletter. Thank you, and have a good one.